Hello. Today we're going to talk about parallelograms some more, and I'm going to call this Part B. We're going to pick up two theorems, and the first theorem says that the diagonals of a parallelogram bisect each other. And remember, we learned bisect means to cut into two equal pieces. So let's look at this example of a parallelogram. Here are my two diagonals. I know that they are bisecting each other. That means that this line is cutting this line into two equal pieces. So I know that this segment is congruent to this segment. So I know that DE is congruent to EB. All right, and then this diagonal is cutting this diagonal perfectly in half. It's bisecting it. So I know that this segment is congruent to this segment. So I know that AE is congruent to EC. All right, the next theorem states that a diagonal of a parallelogram separates it into two congruent triangles. All right, you guys remember, if these lines are parallel, we have alternate interior angles that are congruent. We also learned that opposite sides of a parallelogram are congruent. So this side is congruent to this side, and this side is congruent to this side. We also learned that opposite angles are congruent. So this angle would be congruent to this angle, and then it shares this side, right? So there's various theorems you could use to say that those two triangles are congruent. We got side, angle, side. We could use side, 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 angle, side, angle. Either way, we can say that triangle MJK is congruent to triangle KLM. Okay, let's do some examples using this first theorem particularly. All right, let's look at the first one. It says that LU is equal to 12x, and what they want us to do is solve for x, and it's telling me that every figure is a parallelogram. So LU is 12x. It also tells me that UJ is 13x minus 1, so here's UJ, 13x minus 1. Well, since this is a parallelogram, I know that these are bisecting each other, so this segment has to be equal to this segment. So I can say that 12x equals 13x minus 1, and then we solve it like we would solve an equation. So I'm going to put my x's together by subtracting 13x from both sides. That'll give me negative 1x equals, this cancels, bring down your negative 1. To undo multiplication, we divide, and you get x equals positive 1. And that's it. All right, let's look at the next one. It says RV equals 13. So here's RV, that would be 13. It says VP is x plus 13. All right, I know that these diagonals are bisecting each other so that this segment is congruent to this segment, so I can set these two equal. So I will say that 13 equals x plus 13. I'm pretty sure you know what x is right now, right? To undo plus 13, we subtract 13, and of course x has to be 0. All right, let's look at a couple more. All right, for number 3, it says that NF is 16, so NF is 16, and DF is 5x plus 2. Now, DF is this entire diagonal is 5x plus 2. So I can't just set these equal. They're not equal. This is the entire segment, and this is half of the segment, right? We know that these two sections are congruent. So if that's 16, this has to also be 16. So this entire segment must equal 16 plus 16, which is 32. So I would say 5x plus 2 equals 32. Because if this one is 16, this segment has to be 16 because the diagonals bisect each other. I'm going to subtract 2 from both sides. I get 5x equals 30. Divide by 5 to undo multiplication, and we get x equals 6. So this one was a little different. It gave you the entire length of the diagonal and then half of the diagonal. So you needed to double. All right, let's look at the next one. It says SH is 9. So here's SH, that is 9. FH is x plus 10. FH, again, we have the entire diagonal, is x plus 10. So like we did before, if this is 9, I know that this also must be 9 because the diagonals bisect each other, so it cuts it into 2 equal pieces. So I know that x plus 10, the entire length of the diagonal, is equal to 9 plus 9. And of course, that's 18. To undo addition, we subtract. And 18 minus 10 is 8. All right, let's just do one more. All right. It says that DF is 18. DF, that is the entire diagonal, is 18. And it tells me SF is just this little part right here, is 2x minus 15. All right, so you have a couple options. You could say this segment is also 2x minus 15 and add those together and set it equal to 18. Or if the entire diagonal is 18, what must each half be? If the entire diagonal is 18, then half of the diagonal would be what? What's half of 18? 9. I think that would be the easiest way to go. So we can say 2x minus 15 equals 9. And then add 15. We get 2x equals 24. We divide to undo multiplication, and we get x equals 12. All right, you guys, I hope you have a wonderful rest of the day.